Hello everyone. This video will show how to solve equations involving natural logarithm ln. Now let's go over this first example. So we're given ln of x equals 3. The trick to solve this equation is to think of it every time that the base of this ln is e. So we can go ahead and rewrite this as, so think of it as there is an e here that's lurking, which is invisible, which is the base of this logarithmic expression. So from here, we can go ahead and change this to its exponential form. We will start with the base e. This value right here is our exponent, and this argument is the value for this whole thing. So we're going to write x here. So we pretty much have solved this equation. So our x is e to the power 3 or e cubed. Now let's have another example. To solve this equation that we have right here, we should be left with just ln together with its argument on the left side. So what we do is we're going to divide 2 to both sides. Again, we always remember that there is an invisible e right here so that we don't forget that. So I'm going to go ahead and rewrite this as. So from here, we can go ahead and change this to its exponential form. So this will be our base. E is the base and the exponent is 2. And the argument here will be equal to this whole expression that is x minus 1. So that from here, we can go ahead and isolate x on one side by adding 1 to both sides. So we can go ahead and say that our x here is e squared plus 1. So this is the value of x that will make this equation correct. Now let's have another example. Looking at the example we have right here, both sides have ln. So which means that they both have the same base of e. We can go ahead and say that the left side is equal to the right side. And so it means that their arguments are also equal. So we pretty much have to equal these two arguments, and that would be the value of x. So our x value here is 3. And this makes sense because if we have a 3 here, 3 plus 2 is 5. So pretty much the left side is ln of 5, which is equal to the right side, ln of 5. Now let's have another example. Looking at this example right here, again, we always remember, so we're not lost. We always remember that there is an invisible base here of e. So we can go ahead and rewrite this as, again, this e may not be written in there, but there's an e right there. So we can go ahead and change this logarithmic expression to its equivalent exponential form. We start by writing the base e, and that is raised to the power 2 is equal to the argument 3x plus 1. From here, we can go ahead and solve for x by itself. We can do that by subtracting 1 to both sides. To have x by itself here, we're going to divide 3 to both sides. So we can go ahead and say that our x is equal to, that's e squared minus 1 over 3. So this is the value of x that will make this equation true. Let's have another example. Looking at this example that we have right here, we always remember that if we get an exponent, we are going to use the power property of logarithm. This exponent 3 will become the coefficient of the ln. We put it in front of the ln. So this equation would come out. Now please remember that ln of e is equal to 1. So this equation would come out. Since ln e is 1, so 1 times 3 is 3, and we get a plus 1 right here. So this equation would come out. Now we want to solve for x here, so we're going to divide both sides by 2. From here, we go ahead and remember that there is an invisible base on the ln here, which is e. So I'm going to go ahead and write that so we don't forget that part. From here, we can go ahead and change this to its exponential form. Our base is e and the exponent is 2, and that is equal to the argument x. So we pretty much have solved for x here. Our x is e squared, and this value for x will make this equation correct. So that is how we solve equations involving natural logarithm ln.